Hi, welcome to Grid Down Preparedness. My name's Wade. If this is your first time watching my channel, please take a moment to like and subscribe. It really helps the algorithm. And if you are a returning subscriber, thank you so much. Thank you to our channel members who help financially support this channel. If you'd like more information on supporting the channel, there's a link down below. So let's get into this. This is a honest 1 year plus review of the Pecron E3600 LFP, both in the context of using it as a standalone 120 volt source, as well as using it on 240 volts. It has not been without its challenges. The first challenge that I had was after successfully utilizing the bottommost power station here off-grid consistently for 6 months, living in my RV off-grid with 4 expansion batteries. Other than a few hiccups with it running out of solar one day, which is totally expected, and then some issues indicating that there was an inverter output failure a couple of times. I had an overload message a couple of times, but in continuous operation for 6 months inside an enclosed box, there's a playlist that's going to be at the end of this video that shows all of my videos for this power station. So please take some time and go through that. If you find a video you like, go ahead and watch it. But through all extremes, I've had this thing in ice, below freezing weather. I have had it in summertime inside the box, asking a lot of it to run the RV air conditioners and things like that. And some of the limitations of the unit are it's only 15 kilowatt hours with this unit and the 4 expansion batteries. You're not going to get your full 15 kilowatt hours out because of system losses. Realistically, you're going to get around 12. That's been my experience. If you're using this with solar, I recommend maxing the solar inputs out if you can. It's not going to perform well if you don't have full solar, because if you miss a few days of charging, it takes a while to recover if you're using less than the full input on solar. Don't waste your time on portable, flexible, cheap solar panels, kind of like the ones that I have sitting over here. These were initially bought for my RV. They're rated 130 watts each. Best I could get out of them is about 90 watts each. So don't waste your money on cheap solar panels. What I paid for those 2 panels, I bought a 400 watt residential style solar panel. So go with residential style solar panels unless you plan on using this for camping. Then if you're going to use it for camping, charge it with your truck. I have a video about that in the playlist. So for off-grid camping using residential panels, as far as the price, this unit cannot be beat for 120 volts, 30 amps out, long-term camping and off-grid. It did exactly what I expected it to do. Very few problems with that. Now, let's get into what happened when I decided to put these into storage. So when I finished building this house and I moved in, I disconnected all of this off of my RV, and I wasn't really planning on doing anything with it. I would put my solar panels up, and this was just sitting in my bedroom being used for storage. Well, I had an incident where I decided I want to do some more testing, and I needed to use this for something. So I hooked up this portable air conditioner unit in my bedroom to use as a bedroom air conditioner to try to reduce my power consumption. Well, that unit over there, I didn't realize actually had quite a bit of inrush current. Now, each one of these units is rated for 7,200 watts. I can tell you that it is a toss of the dice if it'll actually go up that high or not. I've seen it trip off at 37. I've seen it not trip off and actually output 3,900 watts continuously. it's kind of hard to catch a snapshot of surge from one of those portable air conditioning units, and that is a 1-ton portable unit. So that is asking a lot from these power stations to run that. It did run it without a problem until it became a problem. I woke up around midnight, noticed the air conditioner wasn't on. I looked at the power station, and it had an inverter output short circuit. I tried every type of reboot procedure. It was about a week and a half to 2 weeks of emails back and forth between Pecron and myself for them to finally send me a return label to slap on the box that this came in. Keep your boxes. These things, if you get the extended warranty on it, you're going to need the original box to ship it back. Trust me, these things are packed amazing. And the box has survived 4 trips with FedEx handling and came back intact. So kudos to Pecron for packing these units exceptionally well. It got repaired, came back, and then while I was waiting to receive this unit, I went ahead and ordered that unit. Because they honored the warranty on this, I decided to buy a second one. And also, main reason for buying the second one is I had these 4 expansion batteries and hurricane season was here. And there was a time where I thought I might get a storm. So I decided to pull the trigger and buy the second unit. So let's talk about 240 volt operation. It works. I did it successfully for 43 days. Took this house completely off grid. Now there is a few caveats to that. Understand that this unit has a max output of 3,600 watts each. There were times where it was exceeded by 1 to 200 watts on one power station or the other, and it did handle beyond the rated capacity of the units. So that's another thing that you folks need to be aware of. If you're still watching, please subscribe, because I have more exciting content coming later. Now, something such as a hot water heater, that water heater right there pulls on each leg of 120 volts around 2,400 watts. And that is a lot of power to split between those two power stations. So you'd have about 24 on the top, 24 on the bottom, and then whatever your baseline loads are. So it was common to actually see 3,000 watts continuous going out while the water heater was on. Now I'm back on the grid right now. This is not hooked up to the grid. It's just out into my generator plug, and that's where it's going to stay because we have a winter storm coming. It's going to be 20 degrees, and my power company is not the most reliable. So that's why it is hooked up. It's ready to go. All I have to do is flip a breaker. That's where we're at. But I did have a same fault on this top unit. So the new one that I bought, the second unit, had an inverter output short circuit. I was talking to Pecron. We were discussing that maybe it was an issue with the 240 volt hub. They had me do a whole bunch of testing, and I was ready to say, all right, I'm tired of testing. Send me a label. I'm sending the unit back. And I decided on my own to get it ready for shipping. I used the 12 volt output and this goofy thing over here. This thing right here and a couple of fans to pull that power down to 50% because you're not supposed to ship LFP batteries at 100% state of charge. So I drained as much power using the 12 volt output as I could. Now, a couple of caveats. This unit still has the solar output that's functional. Even though I couldn't get 240 volts out, I essentially had a stack of batteries that was 18 kilowatts that I still could have used 120 volts. So if you were off grid and getting a return is not an option and you can function on 120 volts, that effectively acts as a second expansion battery. And how that works is this cable right here. This, I call it a DC bonding cable. So what that does is that hooks up this port to this port and allows either unit to balance and draw power from either power station. And I've tested it where I've put a heater and plugged it directly into one unit, and both power stations drain their battery banks down together, just supplying output there. So that's a little something out of the box that you guys might not be aware of. Pacron does not sell that cable. I made it. There's a video on the channel about that. Later on, I did some charging experiments. You cannot charge this from the power grid while it is outputting 240 volts. And no, you cannot unplug the data cable and try to trick it into charging. Because what happens is this power station and this power station, their frequency will start drifting. There is a video about that in the playlist showing how the voltages drift. And that was done when I was testing a 240 volt hub. This does not have a bonded neutral. You would have to use a bonding plug if you were using it for something like EV charging that needs a neutral and ground bond if you were using it independently. The reason that is the case is because if you use this in the configuration that I have it now, the bonding point for ground and neutral is at the main service entrance where power comes into the house. So that's an important consideration when you are using these units in that setup. So don't use a bonding plug when you are connected to your house electrical system. If it's completely standing alone off grid, go ahead and use a bonding plug only if it's required for your application, such as charging an EV or something like that. I had to make a bonding cable so I could charge a Tesla with that, and that actually works with a bonding cable. And I got lucky with that generator. The total harmonic distortion is well below 3% because a Tesla would not charge with that generator if it wasn't. So just kind of a quirk of that particular generator, and it worked out pretty well in testing. Anyway, I digress. Back to these E3600 LFPs. Is this a permanent off-grid solution? No, it's really not. I would consider this an emergency backup solution to whatever you have as your main power source. Coming up on the channel, I am going to partner with Signature Solar, and I am going to get a 1200 watt inverter that connects to the house along with I think 30 kilowatts of batteries here at some point in the near future. So subscribe. I'm going to be going as in depth and going through all of the testing and troubleshooting for a year or more like I've done with this unit. This is not the last video on this power station. I'm going to keep reporting because these are in the market still. They're still available. It's their flagship power station. There's a 3800E LFP that doesn't support 240 volt out, but it's supposed to have like 4,200 watts output. So it must have a different inverter board on it, or they're just running the inverter board that's on this at a higher output. I'm not entirely sure. But it also has a larger battery. There's also the F5000, and a couple of you folks have asked me if I was going to get one of those and test it. If Peccaron wants to send me one for testing, I will definitely test it. But I'm not going to buy one because I'm going to invest in a more sizable option. But my grid down preparedness plan right now is if I lost the power grid, this would be my go-to backup power source. And I am confident that this will function as designed. However, I will not be able to run my heat pump with it. I've tried everything I can to get my soft start to agree that it's okay to run. I have successfully got it started twice, but it shut down. And it was not because of this power station. It was purely because of my soft start. My emergency, if this were to fail on 240 volt output, I would still have 110 volt output. And I would have to do some reorganization on breakers to make sure that I could run the critical stuff in my house, such as my deep freezer, my refrigerators, and things like that, because they're on different circuits. So my emergency backup to these power stations is, of course, this thing. On a bad solar day, how do you recharge? Well, there's a couple of options. You can take your house off the power grid and you can charge both units with that generator. There's a video in the playlist about how to do that. Secondly, there is another option that requires babysitting. So you can either use this generator here or this 120 volt generator over here and a cheap golf cart charger that puts out 20 amps at 58.4 volts. These batteries are not 58.4 volts, which is why you have to keep an eye on it. And that charges both units simultaneously through the bonding cables and power distribution blocks on the positive and negative. And then it has a 50 amp Anderson connector that connects to that device. And you can charge like that with 240 volt outputting. In addition, something that I haven't demonstrated, but you could do, you could use another solar input source or another generator source and a larger unit of one of these and go in and put significantly more power into the power stations. I would not go over 3,000 watts of charging through those cables, though. It's kind of what I've seen. The standard on this is about max charge rate of 300 watts. You may damage the batteries if you try to push more power than that at one time. Oh, okay, excuse me. So, to recap, I do recommend it. If you are in the market for a cheap portable power station, currently, I don't think there is a better priced deal on the market. They have their faults, they have their quirks, but as far as being able to use something and it perform the job, this had fit the bill for what I want it to do. And it is still going to be my go-to power station as far as cost and flexibility until something else much better comes along. Maybe with solid state batteries, I may consider an upgrade to this system. But as for right now, I am giving a recommendation that if you are in the market for a portable power station and cost is a major factor in your decision, this is cheaper than Bluetti solutions. It is cheaper than EcoFlow's solutions. It is quirky. It does have its issues, but my experience has been that the company does honor its warranty. So thank you so much for watching. If you've made it this far into the video, I really do appreciate you. Consider subscribing. Please become a channel member, help support the channel, and have a wonderful day. Thanks for watching.